Hello, Majid. How are you?
Thank you. How are you, Milad?
Thank you very much, and thank you joining me in this meeting. And it's a long time ago that we were talking about data pipeline and what's the difference between Kubeflow and Airflow. That was a good talking actually, and thank you
Yeah,
for joining me in this meeting.
yeah. Thank you. So I learned something new from you, and yeah, I think we can share this. We decided actually to share this discussion with everyone that is interested to the data pipeline topics.
Yes. Because I thought that it is very common question from at least the majority of my colleagues that what's Airflow and what's Kubeflow? In a lot of meeting that maybe my CTO asked me why do you aren't going to use Kubeflow instead of Airflow? And as you have a very professional man, as I understood in last meeting that you are very professional in airflow,
Mhm.
so it can be very good meeting for everyone that wants to know what's airflow exactly and what's Qflow exactly. And so that's it.
Yeah. Actually, I'm working mostly on the DevOps side and infrastructure side of data pipelines, but I work with workflow in this kind of pipeline. So it's actually, I want to just add that I'm not a data engineer or data analyst. I'm going to explain the airflow from my point of view as a DevOps engineer that mainly work to implement it and also work with the pipelines, work implemented Airflow on the Kubernetes, and I have good insight about the probable issues, probable requirements that Airflow needs in a data pipeline environment.
Okay, so as a first question, what's airflow, Magic?
Yeah, simply it's a tool that uh, we are using for uh, scheduling and monitoring workflows and data pipelines.
So, simultaneously with your speaking, I shared my screen and
Mhm,
I know you already made these slides. So we can
mhm.
talk about these slides. And although I have my slides, which is focused on Qflow, and after that, maybe we can focus on those.
Sure. Maybe we can start with your slide and then we can continue the
Okay. So,
airflow
uh,
topics. Yeah, but
okay.
maybe you just hit that slideshow to make it a little.
Okay. Is it okay?
No, you if you hit that slideshow in the top right of the page, slideshow
Is that
button.
true? Top right? Uh-huh. Okay.
Yeah, yeah, yeah.
Okay. So, Qflow is the specific tools for managing ML cycles, machine learning cycles.
Mhm,
And in machine learning cycles, we have a lot of different steps, and for each one, it's better to have a reliable infrastructure for made everything automatic. Okay.
mhm,
Unfortunately or fortunately, a majority of developers, especially AI generative developers, just thinking that machine learning development is just coding and something like this step. But actually, it has a lot of different steps, and for managing each of them, we need a specific tools. Okay.
mhm,
Uh, Beside that, each step has its own hardware infrastructure, and we have to have a software to manage all of these. For example, in as I wrote here, a training phase is resource intensive, while an inference phase is lightweight and speedy. So we need to adjust the requirement, especially the hardwares, for every step. You know, for example, in the training phase, you need, let me say, 16 CPU core. Okay.
Mhm.
So for another step, you need just two CPUs core. Okay. So we need to have the infrastructure to manage them, and also, it is very important to have a good orchestration. So, right now, I think the best thing for doing all of these is Kubeflow because
Just sorry to interrupting you. Just before coming to this slide, in the previous slide, you mentioned inference phase.
Mm,
Could you please
yes,
explain it a little?
yes,
What is this phase? Because I'm hearing it and I'm reading it in many topics, but yeah, also for me it's a little not clear. What is this exactly this
yes, yes,
phase?
yes, sure, sure. Good question, actually. After training phase of model or fitting the model,
Mhm.
showing some different data sets to model in order to train the model, we need to use the model in our production environment. For example, think that about a model that can find a cat in a picture.
Mhm.
Okay, so you have to show a different type of cats and picture to model in training phase. And after that, in the production environment, you need to show new data sets to models. For example, new pictures that have cat or have not cat. Okay, cat
Okay.
in jungle, cat in street, something like that. Okay,
Yeah.
showing new data sets to model called inference phase.
Mhm.
So it is not very complicated phase. It is not very hardware consuming phase here. It's just giving new data sets and then short processing and then taking feedbacks of the model. So it is very lightweight and speedy. So we can do it with lesser hardware than training phase. Okay.
Yeah. Yeah.
Uh,
Thank you for your explanation.
okay. So right now, I think Q4 do all of these based on my current experience uh, in a best way. So let me think. As I said, we have a lot of different steps in machine learning. Think about these steps, and we can consider them system one step, for example, because we call
Mhm.
them system steps. That's just a naming,
Yeah.
nothing important. Uh, think phase one, for example. Uh, we have to do some process in our data. For example, data ingestion, data analysis, data transformation, data validation. Uh, uh, right now, I know, I'm pretty sure that a lot of teams, departments, even in AI companies, do all of these steps manually. I'm pretty sure. Okay.
Mhm.
But it is our responsibility as MLOps manager or DevOps manager to provide reliable infrastructure to give them the opportunity to do all of these steps automatically. Okay. So, so why we need Kubeflow? Because Kubeflow provide you pipeline. Very beautiful pipeline, and let me show you yes, for example, that's a pipeline in Kubeflow, and even from artistic point of view, it is very beautiful for me, actually. And we
Yeah.
can add, and this software can automatically produce the DAG as you see here. And you can see the each steps of the pipeline. For example, this is the pre-process data that is, and this steps is exactly this step. Sorry, sorry, what happened? This step, the green, the green step is exactly
Mhm.
this step. For example, the
Yeah.
training the model step is exactly this step. Okay, so this tool will help you to generate the DAG, generate the pipeline, running the pipeline, and also isolating the pipelines in machine learning environment. But when I come back to our previous meeting, I think Airflow is something exactly different. Uh, that's at least in my understanding. You can explain it later, actually.
Yeah. Yeah.
Uh, but
Yeah. Also, in Airflow, we have this uh, same concept as DAG, and the DAG consists of some task or steps to extract, transform data, and then load to a analytical database. Yeah,
Mhm,
but yeah,
mhm,
the thing is that it's more about the uh, analytical data and using data for analytical purposes. But here you are maybe more talking about the models that
mhm,
train for some purpose.
So it is the focused or a special tools for machine learning problems or issues. But I think
Mhm.
the Airflow is special tools for managing the data in in different flows.
Yeah, orchestrating data pipeline. Yeah, then
Mhm,
we have some inputs. We want to transform them and then load them to a data warehouse. Then
mhm,
mainly using that process data or transform data for analytical purposes.
mhm, mhm, mhm. Uh, so, if I want to come back to my slides and continues the Kubeflow features, another feature
Mhm.
is that Kubeflow actually extend the Kubernetes ability, and it is heavily depend on Kubernetes. Actually, without Kubernetes, you don't have Kubeflow. Okay,
Yeah.
and it is based on the Kubernetes orchestration, based on Kubernetes pods, based on Kubernetes scheduling. So without Kubernetes, you don't have any Kubeflow. And it's very important because in some steps, for example, in model fitting the model or a model training section, you can extend the infrastructure and use a considerable number of volumes, memory, and even storage. But in the another steps, like I said in previous slide, you can reduce the using of the hardware. Another important thing is to managing the GPU. Imagine using managing the GPU in model learning or machine learning is very important, as you
Yeah.
know, because GPU are very expensive devices, and right now, I'm pretty sure again that in a lot of department in organization, each teams has its own GPU, and they can just use GPUs, for example, 2 hours a day, you know, and
Mhm.
and it is especially allocated to that team. So with Kubeflow, we can share the GPUs across the organization, and then we
Mhm.
can make sure that 24 per day, 24 hours per day, GPUs are under pressure or under using actually. So
Mhm.
for me, and even for my organization, for my CTO, this is very huge benefit of using Kubeflow in the organization. So just
Yeah.
by having uh, maybe, for example. two or three core of GPU or a slot of GPU, you can do all of things you need. But before that, every team has its own GPU or even virtual machine. So from this point of view, using Kubeflow in machine learning would be very beneficial, actually.
Mhm.
If I want to say another thing, Kubeflow has multiple components. That is not just running a pipeline. Kubeflow will provide you multiple components, including Jupyter notebooks,
Mhm.
as it's as a built-in component. So you will have its own notebook. You will have your own notebook, your own storage, and another important thing that is Kubeflow support multi-tenant functionality. So you can allocate a special predefined hardware and storage for each team of organization in an isolating environment. So, for example, NLP department can have two GPU, 16 CPU, 24 gigabytes of memory, and 10 gigabytes of storage. Another team can have same hardware but in isolating environment, and I think it would be very beneficial too for
Mhm.
AI organizations.
Just one question here coming to my mind is that the for example, when you say there is a Jupyter notebooks, so the tasks or pipelines are mostly scheduled tasks or pipelines. They are running, for example, hourly, daily, or they are mostly on-demand tasks. For example, you want to run some task for a while to train a model on some data set, and then that's done. And then, yeah, maybe you have the new use case or new request. So what is the nature of the pipelines in this Kubeflow world or this machine learning training models world?
Actually, Q4 has its own deployment for managing the pipeline. And
Mhm.
for example, you can see this is the one step in pipeline, but behind the scene, if you're watching your Kubernetes cluster, you will have it's automatically built at I think four pods for each steps of the pipeline. Okay, one pod
Mhm.
is for generating the DAG, another pod is for considering the authorization, I think, and something like that. Okay. So the
Mhm.
nature of the pipeline is this special deployment in the Kubeflow that generate the pipelines based on your order in the Jupyter Notebook uh, Python code. You know, the pipeline in the Kubeflow is the Python codes. Okay, based on the
Mhm.
KFP library, you have to import the KFP library in the codes and then run that. But you have two environments for running the pipelines. You can directly run your pipeline from the Jupyter notebooks, which is just a Python code, but you can generate a file, which is a YAML file, for uploading it as a pipeline. For example, I can generate a pipeline in my local laptop, okay? And then I will send you that YAML file that in your Kubeflow, and then you can run it in the cluster. Okay, so this is the another functionality of using the pipeline. So maybe someone wants to develop the pipeline in her or his laptop and then send it to the I don't know Kubeflow administrator, and then we can run the pipeline in our huge infrastructure, including a lot of nodes, a lot of GPUs worker, and something like that. So I think I try to answer your question. If
Yeah,
it's
yeah, yeah. Thank you.
okay. So, like I said, this is the environment for making your notebooks, and
Oh.
even you can allocate the special set of hardware to your notebooks. Even this is not only just for pipelines. For example, you can say to the Kubeflow, "Hey Kubeflow, for training model, I need four V100 GPUs in my cluster. Okay. But for evaluation the model, I need just two CPU. Okay. Even
Mhm.
you can say to Kubeflow in your running your Jupyter notebook, you can allocate CPU, RAM, and even GPU and even the workspace volume based on your needs. Uh, of course, you have to have the requirements in your class. Okay, think
Mhm. Yeah.
consider it. And also another important component is the built-in tensor board. Because after training the model, after inferencing,
Sorry for interrupting you. Did you share any slide? Because I don't see anything in the slide. It's only the template.
really, um,
This one I can see. Yeah, yeah.
okay,
Now it's showing me.
it is a
Okay.
tensor board
Mhm.
TensorBoard component that you can expect to see the related diagrams. Actually, for example, after each step of running, for example, what's the epoch accuracy, what is the epoch loss, and it can be very helpful for the AI developers. So it is connected to the Jupyter notebooks, it is connected to the pipelines, and it is live. So after each training phase, after each running of pipeline, you can immediately see what's the result of that. So it would help the AI generative developers. And another important thing is creating an experiment which is related to hyperparameter uh, manual manipulation actually. And another important thing is to scheduling a pipeline based on different triggers. You can define the start date. You can define the period of running the pipeline. For example, you need to run the pipeline every hour, every day, every week. You can easily define these, and you can easily run the pipeline based on different triggers, based on different criteria. Uh, uh, I think these are the comprehensive solutions for those who want to have as unique infrastructure for the MLOps. Although running the Kubeflow is a little bit complex, and but after running it, you can enjoy it. Actually, enjoy running it in different level of organization. So
Mhm.
that's it from my side about what's
So,
Kubeflow.
so here a trigger means that, for example, it will run this maybe pipeline at
Mhm.
the scheduled time. Yeah.
Yes, it's about scheduling a time. You can even connect your pipeline to a GitLab repository and trick your pipeline based on the changes in the GitLab repository. For example, after accepting a merge request. So
Mhm.
I think it is very interesting option. And after just accepting a merge request, the pipeline will trigger and run. So, these functionality would provide. Another important thing. Sorry, another important thing is the queue functionality. Because think
Mhm.
about if you have 10 department in organization and all of the organization put the running buttons simultaneously, the queue will put running them on the queue, and we can
Mhm.
make sure that their pipeline will run in the appropriate order actually. So it is
Yeah.
another important thing for you running Kubeflow. So that's it. If you have any other question, I'm here.
No, thank you. Let me also explain the airflow maybe, and then maybe we can also discuss a little bit
Mm,
more about the difference. Actually, there are two different tools for two different approach of data pipelines. But yeah, we are not
yes,
going to compare them directly. But yeah, we just want to see what is the workflow and what is the use cases for each of them.
yes, yes. So I think we can continue with your airflow slides, and then we can
Mhm.
wrap up the
Sure.
session. Okay.
Maybe I can share my desktop because I
Yes,
also want
it is
to
better.
show the.
Let me
Uh,
stop the sharing. Test.
okay, let me share here first. Okay. And, yeah, okay. Yeah, then as I said, Airflow is an open source platform. At the beginning, I would say that it's an open source platform that let you author, schedule, and monitor your data pipelines. The main components for Airflow are the scheduler, the executor, the workers, metadata database, and also web interface. So user can work with also this web server that providing a web interface. But yeah, the main components in the heart of it is that scheduler that uh, uh, actually processing the DAGs, and then the executor will decide to how to run that task inside the workers.
Mm,
So then also we have an metadata database for Airflow that the scheduler use for maintaining the state of the tag and task, because it's not only one scheduler in the production environment. We are going to use multiple of them. Also, regardless of how you deploy a scheduler, for example, in Kubernetes environment, you can use a simple deployment, or you can also use a stateful set to have some state for a scheduler in your cluster. But at the end, you will have a metadata database that it can it actually contain. It's connected to scheduler, to web server, and workers, and all of them reading and writing data to this metadata database. So the core concepts of the airflow is tags. It's directed acyclic graphs that I will explain each of these words in the next slide. It's a collection of tasks that organize to represent workflow dependency. So we in the DAG we mainly organizing the task. The tasks are the individual units that uh, defined in the DAG, and also they are defined by operators. So operators is the execution of these tags, actually the commands that executing the tags. And also we will see we have different type of operators, like Kubernetes operators, like other operators that we can use. And it's one of the good features of Airflow that you have different operators, and also you can develop your own custom operator to run some to execute some logic in your DAGs. The scheduler, as I said, is monitoring DAGs and tasks, and also when all dependencies of a task is met, it will run that task. An executor here, it means that it's determine how to assign the task to worker, and then how the task will be finally go to be executed. Directed in DAG properties, it means that, as you can see in this picture, it means that task can be either upstream, downstream, or parallel to another task, but uh, there is a clear direction. You cannot have like this non-directed dependency between two tasks. Also, is acyclic means that there is no circulation between the tasks, and yeah, these two uh, properties of tags are important to uh, know and also to consider when you are organizing your tags. Here we can see the different states of task. For example, at the beginning, scheduler will be schedule the task, and then executor will be queue it, as you explained, for example, in the ML Kubeflow. Here also in the Airflow, we will have task first in the queue, and then workers based on their capacity and their algorithms will pick the task from this queue and will run them. After run, the task can be success, can be failed, can be shut down, and based on the policy, you can do, for example, retry for the failed task, and then again they will be go to the scheduled state. And yeah, these are yeah.
Is this the real DAG in Airflow, is or it's just architecture infrastructure?
This is a task instance
Uh-huh.
state. You know, a
Uh-huh.
task will be in the schedule, will be in the queue, will be in the
Uh-huh.
running,
Uh-huh.
will be in the success phase. Yeah, this is the state machine of a task, that
Uh-huh.
which state a task can have.
Uh-huh.
These are the different states that the task will have. But yeah, a DAG is actually a collection of these tasks that a
Uh-huh.
scheduler will check, for example, as I said, to see if the dependencies are met, and then it will be run by the workers at the end. Executor will put it in the queue, and then worker will run the task.
Uh-huh.
The use cases are for data pipeline and ETL to extract, transform, and load the task, automating this kind of ETL pipelines. For machine learning, for example, you can use also for training and pre-processing of the data. For big data processing, for example, there is a good uh, capability of Airflow. You can use it with other tools like Hadoop, Spark, or Kafka to distribute the task. Yeah, because at the end it's an orchestrator. And yeah, for BI and reporting, you can automate workflow for dashboards, for example. It's a very good use case for Airflow, that you can define some scheduled uh, task to run, to transform data, and also to push to analytical database. Then you can use it for reporting. And also for event-driven workflows, like when a file is uploaded, when there is an API call or any custom condition, you can use also the Apache Airflow.
Majid, can we edit or manipulate the data, for example, in our pipelines in Airflow? For example, changing the value in a JSON file or changing the
Yeah,
value.
yeah. That transform means that you are going to change the data.
Mm-hmm. Mhm, mhm.
Yeah, I will show an reference architecture in the coming slides that how we
Okay.
are using or Airflow. But yeah, it's the orchestration layer, but then you can do everything with data as you need. Then a strength of it is that it's modular, and for example, you can, as I said, you have different type of operators that you can use, and also you can develop your own required operator. It's yeah, actually, Airflow itself is written in Python, and also the tags are in Python language, so it's very extensible. You can use Python scripts for any specific task that you need. You can use for different type of requirements, because yeah, you can write your requirement in your scripts. The visualization that web UI provide is also it's a good things for data analytics or maybe data engineers that want to work with the pipelines. It's very scalable. You can use it with executors like Celery and Kubernetes, and yeah, and one of the most important strengths of Airflow is integration. It's compatible with many third-party tools, and we can see in the next coming slides how you can use it, for example, with DBT or other tools for ingestion, for transforming data, for actually integrating with other tools, as I said, like Spark or Hadoop. So it's very important. It's a very important strength that you can integrate it with many other pipelines or tools. The limitation is that it's not real time because it's designed for batch processing. So we cannot expect that we use it for real time use cases. The dependencies, the task dependencies can be hard to manage actually in terms of dependencies of them. The retiring mechanism is not that much good, and you need to also sometimes build some custom logic for it. There are retire mechanism, for example, when the task is failing, you can use a retire to just uh, uh, use run the task again and to succeed it. But yeah, you need to implement some custom logic for them. Debugging overhead, it's one of the issues that I see a lot in my day-to-day work, that yeah, debugging is very hard, but when you are working in data world, you also need to use the data that you have about work, about the workflows, about the airflow, about from the logs, and actually uh, it's again one of the good things that you can use airflow for improving airflow performance. It means that you can use your log data to analyze and also create some BI dashboard, for example, for them. I had actually a very uh, special experience that I want to create a dashboard for some task failures, and I couldn't do it in these regular monitoring tools like Grafana or
Mhm.
DataDAG. So at the
Yes.
end, yeah, we find that okay, we can use the uh, pipeline for analyzing our logs and then creating some SQL table, and then using some dashboards, I mean BI dashboards, to visualize the pipeline failures, and it helps us to improve the failure rate, I mean to reduce it. And yeah, it's one of my actually good experiences to use
Yes.
it for use
Yes.
Airflow for debugging itself. And
very
yeah, the
previously, actually.
as I said, it's provided very basic monitoring. So as I explained in this example, we need to create some pipeline to understand the logs from a scheduler and task, and then uh, we can simply detect and fix the issues in the pipelines.
Mhm.
Yeah, here is the reference architecture that I got from a Medium article. Actually, it's about uh, pipeline on Google platform, mainly BigQuery as an analytical database. But as you can see in the left side, we have these databases and application as source as input. So as I said here, we are going to use some data for mainly analytical purposes. So we have databases, we have applications, and we are using them as input. Then we have a extraction and load layer that we can use ingestion tools here because it make it for if the tools already support the integration or connection with your inputs, then it will take the things very easier for you. And here, as you see, that airflow on the bottom of this architecture as an orchestrator. So from the extraction layer, you can use, for example, Airbyte. Again, it's another tools that you can use in combination with Airflow to
Mhm.
ingest your data to the landing zone. Landing zone means that you are only ingesting data as is. You are not going to change it because we are not going to mix issues here. We want to see if there is any uh, issue in the data. It's not introduced in the ingestion tools. So ingestion tools easily uh, uh, just getting data from source and putting in it in the landing zone. So here in the BigQuery, we can check then if there is any issue. So because we have a term garbage in, garbage out. So if you have some bad data, not qualified data, then the output will be the same. So then we can run some integration test or other type of test on this landing zone. And then DBT also is another tools that is like actually the template for SQL. As if I want to say very easily, it's a template for SQL, like the uh, other templates that, for example, we have for YAML files. Um, so with that, you can uh, transform your data once or multiple times to
Mhm.
move data between the states. And then again, it is the Airflow capability to integrate with your ingestion tools, with your DBT, with your BigQuery, with some libraries, some operators, and then you at the end of this flow, you are going to uh, push this data for distribution layer. That means maybe you need some dashboards like Looker. You need to deploy it to some ML models. You need to deploy it to some APIs. So it depends on your requirements. So this is an example of how Airflow can integrate with different type of requirements, different type of tools, and then orchestrate your end-to-end data pipeline from raw source data to something like dashboards, APIs, or yeah, this kind of outputs.
Mhm. Mhm.
Yeah, that is yeah. My also let me share. I'm running uh, Airflow here locally.
Oh, do you have it locally? Oh, sounds interesting.
Yeah, yeah. I'm running it locally, so it's the UI that we said. You can go there and see your DAGs. In the newer versions, they added this cluster activity that you can check your pools slots, you can check the state of your DAG runs. I will explain what is a DAG run, but yeah, you can see DAG run types, task instance status, and for example, here we have task in success or escape.
Escape. Mm-hmm.
Yeah, you can see these things here. Yeah, if you go to, for example, some example DAGs that I enabled, for example, this is an example bash operator DAGs that running. Each of these actually runs is a DAG run. So, for example, we schedule this DAG to run, for example, hourly. So in each DAG run, it's going to run the task, and in the task, you can go and see, for example, what is the logs. Logs means output of your task.
Yes.
So, for example, you can see that here we have a command that's running inside this bash operator like this bash command
Mm.
that doing nothing, just sleeping for 1 second. But yeah, here also we have some tasks that we skipped, and yeah, it's not doing anything special. You can see the dependencies of task here, how they are dependent to each other. For example, we have some tasks that dependent on other tasks, and some of them are running in parallel. And yeah, detail of the task, you can see what is the, for example, pool that it's using, what is the
What's the full actually here?
actually pool. It means that when a scheduler want to run the task, it's using this pool. It's
Mm.
like a, for example, pool of resources that it's going to
Uh-huh.
use,
Oh, okay.
yeah, to run the tasks.
Okay, fine.
Yeah, you can see also the code. As I said, it's a Python code
Python.
that you can define, yeah, your requirements as task steps in this DAG. And for example, another DAG that I have here for is, for example, tutorial DAGs. But again, you have see we have three DAG runs here, and here it's again bash operator. It was different. Let me see this. Yeah, for example, here we have Python operator. Yeah, as I said, we have different type of operators that we can use
Extract,
for
transform,
our.
and load. It's very simple for
Yeah,
Python. Am I
yeah,
right?
yeah,
Mm.
yeah. It's very simple, and we can see, for example, it's like an extract, transform, and then load. But yeah, we are doing not actually nothing here in these steps. But yeah, it's a very simple tutorial deck that show how you can use the dependency between tasks. For example, first extract with some operator, then transform with other one, then load with other one. Yeah, yeah. This is overall the UI of Airflow, and you can see, for example, the tasks are in uh, what is based on the colors here. You can see that what is the state of the
The
task.
state
It's
of each test, yes.
yeah, it's deferred, it's failed, it's queued, it's
Mm.
removed, it's restarting, it's running, it's success. Yeah, you can see. Yeah, but yeah, here also you can Gantt charts. These
Can see
things
the
are
order.
actually helpful, especially for data analysts or data engineers to see what's happening in their tags. They have this UI to use for their day-to-day task.
Mm, mhm, mhm.
Yeah,
That's
so
so
let
interesting.
me
Thank you
stop
for
now. Yeah.
showing us these dashboards. And because you were able to run your referral in local.
Yeah.
device actually, but I'm not able to run the Kubeflow in local device because it at least needs at least 16 CPU just for running, and because of my NDA
Yeah,
contracts and agreement, I won't able to show my organization
yeah, yeah.
Qfollow. And so showing this dashboard was very interesting for me, even for me. Thank you for that.
Yeah, yeah,
And
yeah. Yeah, it's very easy. You can run it your laptop
mm,
and it's don't need actually a lot of resource. You can run and experiment, yeah, the things in your local machine. So
mhm,
it's very light application. Yeah, in the production, as I said, you have many consideration to have a production ready airflow. But yeah, for example, on Kubernetes, you need to uh, yeah, it's not. I think I also it's not bad if I explain a little about the implementation type of the task in a Kubernetes environment, for example. Because as I said, for example, the scheduler check the dependency of the task and then executor will be decided how you are going to run your task. One
mhm,
of the issues that, for example, I see is that when you are running a task inside the Kubernetes,
mhm,
it's the airflow that scheduling and running the task inside the Kubernetes. So at the end, it will be just a pod. There is no deployment or controller behind it. So you need to take care of the failure fail task because yeah, it's a pod. If it
yeah,
fails,
only a
there
part.
is nothing to control it. Yeah, then yeah, you can, as I said, you can use some custom logics to understand if it failed and then retry that. But again, there is no guarantee that the retry task will not fail. For example, let's say you are going to use spot instances because we are not providing any live uh, web service. We are handling some batch task.
Mm, mm,
So here it's very common that you can
yes,
use spot instances.
yes, yes,
But
sure.
if that spot instance fail and your task fail, then you have some issues. If at the failure moment you can catch the failure state in your even in your scheduler because it's at the end it's a path.
Yes, yes, yes,
Yeah.
yes.
So there are some challenges that you have to, for example, uh, control and manage the failure of this kind
Failure.
of task.
Mm, mm.
Yeah.
So the failure handling in Airflow would be very challenging, actually.
Yeah, yeah.
Mm,
And also, for example, you can use Celery, then you need to have other requirements that Celery needs to queue task and how run them. For example, Celery will be a pod, but inside that pod, you are going to run multiple tasks. So if that fails, then you also need to understand how you can handle these things. Yeah. So in the production environment, these kind of challenges you will have for running tasks, how do you handle the failure, at the same time uh, optimizing the cost because you can simply not use the spot instances, but then you have to pay more money.
okay, thank you for your comprehensive explanation about the airflow and your real world challenges that you're facing them in your real world working place. And that was very interesting, at least for me, for knowing more about what's exactly the airflow. And for wrap up, if I want to say, although in both environments we have the same concepts, for example, pipelines, DAG or data or writing even pipelines in Python. And
Yeah.
although we can do some tasks in both platforms, actually, I think
Yeah.
you can run even machine learning pipeline in Airflow. That's
Yes.
you can do it. And even you can run the data transformation pipeline in Kubeflow, as it is a Python-based pipelines, and you have Jupyter notebooks, and you can do anything you want actually. But
Mhm.
they are focusing on different work actually.
Yeah.
The Kubeflow is just focusing for machine learning process and do nothing about changing in raw data into the data that would need for the dashboards or other analytics
Mhm.
situation. But in
Yeah.
Airflow, we want to manage the data and manipulate the data in order to provide and make them ready for using for analytic purposes. And even we can use those data in machine learning
Yeah.
pipelines, but we have a good tools for providing a good data for machine learning, and it is good. I think, like I said, although we have same tools and we same concepts, but it's better to draw a border between those and think about using those platform in their places actually.
Yeah. Yeah.
And at least for me, this session was very at least shed a light on my brain
Mhm.
because, as I said, a lot of my colleagues, even AI developers like me, yeah, have you ever heard NiFi? Watching NiFi actually? It's
No. No.
it's another tools that working with data and my colleagues tell me we have to use NiFi, we have to use Airflow. Why we need to use Kubeflow? And maybe you have some problem in your department for using maybe Kubeflow instead of Airflow. I don't know. Just thinking about that, thinking loudly actually.
Yeah.
So that was very interesting meeting for me, and I'm going to publish this meeting in my YouTube channel. And I think after that, maybe someone's ask us to learn Airflow or Qflow, and I want to take ask you to give me some more times if we want to have a tutorial for Airflow for
Yeah.
someone.
Sure.
Maybe someone wants to know what the and as you have very fun, practical experience in this area, you would be the best one for learning the Airflow. Actually, I think so.
Yeah, I also want to thank you because also I learned a lot of things from you in this meeting, also previous meeting that we had together about
Yes.
because it was the question, the first discussion that we had together. What is this and what is the other? And I also learned a lot about the world of the machine learning pipelines, especially for creating models as you explained in your slides. Yeah, and yeah, I try to share best of the things that I know, and yeah, I would be happy if I can maybe write a tutorial or share another video that if anybody is interested to know about the details, then yeah, we can
Yes,
also do the uh, another meeting like this one
yes,
to
of
go a
course.
little.
Yes, of course, of course. Okay, thank you, Majid. Thank you for your time.
Yeah.
Thank you,
Thank
and
you.
bye bye for now. Bye
Bye.
bye.
Bye.